Welcome, ladies and gentlemen, to the last lesson of Quarter 1, Slopes and Lines, Unit 2, Lesson 3. Essential question: how do angles help identify relevant measures in real-world situations? And these are the objectives that we're going to get through today. We're going to use slope to identify parallel and perpendicular lines, write an equation of a line, given information about the graph, solve problems by writing equations. So we're going to first talk about slope. This might be a review for some of you from Algebra 1. If it is not, then please pay attention. Make sure you understand what's going on. This is going to be a crash course in slope. So how do we calculate the slope? Well, first of all, what is the slope? The slope is also known as the steepness. So the more steep something is, it is either it either becomes a larger positive number or a much lower negative number. And the closer we get to zero, the less steep it becomes. In order to find our slope, we need to look at two different dimensions. We look at the change in y, and we look at the change in x. So we first need to subtract from these 2 points, x1, y1, and x2, y2, the y components and the x components. And this will actually give us what we call our rise. Okay, this is our rise. And this would be our run. And if I were to map it over here, this would be our rise. It's a change in y. And this would be our run. And when we actually calculate the slope, we are taking our rise, our change in y, and we're dividing it by our change in x, or our run. So in reality, we can simplify this by just saying rise over run. Once we've done that, we're going to end up with some sort of fraction, and we want to simplify that fraction to its most basic form. It might still be a fraction once we simplify it, or it might be a whole number or some natural number. Let's do a few examples, okay? If we take a look at these examples here, we have the distance from f to g, from s to t, to x to y, to p to q. So let's check this out. Let's look at f to g. F is at 6, 2, g is at -2, -5. Let's start at f and just do our vertical component. We go all the way down till we hit the same line that g is on. And that is 1, 2, 3, 4, 5, 6, 7. So we have moved in a -7 direction, downwards. Now let's move from where we ended our downward motion towards G. And this is moving in a backwards direction, so we have -8. And so in this case, our slope is going to equal -7 divided by -8. And we are going to simplify this by saying a negative divided by a negative gives us a positive, so our final slope is 7/8. Don't change it into a decimal. The decimal won't tell you anything. All this tells us right now is that our slope is positive, so it's going upwards from left to right, and it's going on a pattern from 7 units up 8 units to the right. So every 7 units up and 8 units to the right, you should hit the line every time. Now, let's find this algebraically like we did before. Let's say we want to find the change in y, which would be 2 minus negative 5. This is going to give us a positive 7. Let's find the change in x, which is going to be 6 minus negative 2. This is going to give us an 8. And so our slope, we said, was the change in y all over the change in x, which is just going to give us 7 over 8. And we can see that that is the same answer that we had if we did it graphically. Now, most of the time, you're not going to have the graph to actually find the slope. You're just going to have to find it algebraically. So make sure that you know how to calculate a slope and interpret what that number means. Now let's go to the next one. We're going from s to t, so st. One, two, three, four, five, six, seven, 8. We've gone negative 8. And this time we're going to be moving to the right too. So moving to the right is a positive motion. And so we have negative 8 and we have positive 2. And when we simplify this, this simplifies to negative 4. And what this tells us is that we are moving downwards from left to right. And for every 4 units we go down, we go 1 over 1 time. And so that's going to be our slope. Now let's try it algebraically. 7 minus negative 1 gives us an 8. The difference of our x's is negative 3 minus a negative 1, which is going to give us a negative 2. And so our slope is going to equal 8 divided by negative 2, which gives us negative 4. Now let's find the slope of this horizontal line. Here is a problem. We're going to go from x to y. And so the first thing we want to do is figure out, well, what is our rise? What's our rise? Are we going to start at x and are we going to go up? And we want to go up to where y until we hit the line that y is on. But we're already on the line. We can go down. We're not going anywhere. Okay? So what this tells me is that we're actually essentially going to be not moving at all. But if we're not going up or down, so our rise is 0. And therefore, when we move over to y, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. And so our slope is essentially 0 over 8. And if we divide anything, if we divide 0 by anything, then we're just going to get 0. So a horizontal line, a flat line, is going to be 0. We can even check it algebraically. Negative 1 minus negative 1 is just going to give us 0. Negative 2 minus 6 is going to give us a negative 8. So our slope is just going to equal 0 over negative 8. And no matter what we do, we're not going to have a negative 0. 0 is just 0. It's in the middle of negatives and positives. So we just end up with 0. Now let's look at PQ. We know that if we go downwards from P to Q, we got 1, 2, 3, 4, 5, 6, 7. So we're moving in a -7 run. But uh-oh, look, just like how in the last one, we don't have a run. So essentially, we have a 0 run. We're not going anywhere. We're just going straight down. So how does this look? Well, now our slope is going to be -7 divided by 0. And this, if we plug this into our calculator, it's an error. If we cannot divide anything by nothing. That's saying essentially something is there, but we divide it by nothing, which doesn't make sense. The only thing we can divide by is really, really small things. The closest that we can possibly get to 0, but we can never divide by 0. And so what we would say in this case is this would be undefined. Okay, our slope is undefined. And so in this case, we have a positive slope, we have a negative slope, we have a horizontal slope, and we have a vertical. So if you ever see something that is completely vertical, you know that the slope does not exist. It is undefined. Let's interpret slope real quick. In 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the annual sales were $85.9 million. If sales increase at the same rate, what will be the total sales in 2015? So we look at this graph over here. We need to interpret this graph real quick. We can see that over here, we have the annual sales in millions. But look at where we start, all right? Look at the years. We have 2, 4, 6, 8, 10, 12, 14, 16. We do not have 2000. We do not have 2005. But we do know that the years are from 2000. So this essentially is 0 years from 2000. So we're starting at 48.9 at that moment. Now, at 5 years, 2005, we can see that our 85.9 million is recorded as 85.9. We don't need to record it with all those zeros there. And what we want to do is we want to figure out what is the amount around right this point, okay? Right where we equal 2015. But we need to figure this out. We need to know what is our overall slope, okay? And so we're going to take both of these and we're going to apply them to our equation, okay? So we're going to say, let's say x1, y1 is equal to 0 and 48.9. And we'll say x2, y2 is equal to 5 and 85.9. Let's find the difference in our y's. the difference in our y's is going to be 85.9 minus 48.9, which equals 37. The difference in our x's is just going to be the difference in years, 5 minus 0. And so our slope is going to be 37 over 5. Excuse me. So what does this mean? This means that every year, or every 5 years, we grow $37 million. Holy crap. We increase by $37 million every 5 years. Now, what we need to do is we need to figure out, okay, well, how much money are we going to make over the next 15 years from the start? Okay, so from the beginning all the way there. And so what we can say is 37 over 5 multiplied by 15 years. What that's going to do is that's going to tell us, okay, this is really what this is saying is 37 divided by 5 is 7.4. So we're actually looking at $7.4 million. Okay, we could even say $7.4 million for every 1 year. And so we're going to multiply this by 15 because every 15 years we get that. Now, if we want, we can say 37 every 5 years. Well, 5 goes into 15 3 times. So really what we're saying is we want to say 37 times 3, in which case we get 111. And this is $111 million we had of an increase. But how much are we going to have? We want to know what will be the total sales in 2015. But remember, in the beginning, we started out at 48.9. So now let's actually find this answer. We're going to say the total sales is going to equal, and we're going to take that first number, 48.9, and we're going to add it to our 111 million. And this is going to give us 159.9 million dollars in 2015. Let's talk about parallel versus perpendicular slopes now. We're going to compare two different slopes. and determine whether or not they are parallel, perpendicular, or neither. Parallel lines have the same slope. If we find two slopes of two different lines and we notice that they are exactly the same, they are identical, then they are parallel. In this example here, we can see that the slopes of our parallel lines are both 4. They increase, they rise 4 units and they run 1 unit over both of them. They have the same steepness. Perpendicular lines have what we like to call opposite reciprocal slopes. And that's a tough word, that's a tough term to remember. So just remember that if you take the two slopes and you multiply them together and you get -1, then they are perpendicular. They form a right angle. And if we look at line P with line M, we notice that line M, as we said before, had a slope of 4. Line P has a slope of -1/4. And when we multiply 4 and -1/4 together, we get a -1, and so they are opposite reciprocals of each other. So let's determine whether AB and CD are parallel, perpendicular, or neither. Let's look for the slope of AB. We're going to say the change in y from A to B is going to be -1 minus 5, which we get -6. The change in x we see is going to be -2 minus 4, which is going to be -6. And so our slope in this case is going to be a -6 all over a -6, which just gives us 1. Now let's do the same thing. We'll find the slope for CD. And the change in y from C to D is going to be 1 minus a -2. And the change in x is going to equal 6 minus 9. This is going to give us a 3. This is going to give us a -3. And so our slope is going to equal 3 divided by -3, which simplifies to -1. Now, let's take this, and let's take this. They are not the same, okay, because so we can say that 1 does not equal -1, so they are not parallel. But if we say 1 multiplied by -1, we get -1. And the one thing that and the rule that we said was that if we multiply both our slopes together and we get a -1, then they are perpendicular. So therefore, we can say AB is perpendicular to CD. Let's try this one. Let's see if FG and HJ are perpendicular. I'm going to color code these now. So we're going to say slope of FG. change in y is going to be -3 minus -1. This is going to give us a -2. The change in x is going to be 1 minus a -2. This is going to give us a +3. So therefore, our slope is going to equal a -2/3. Now we have slope of hj. Change in y is going to equal 0 minus 3. It's going to give us a -3. The change in x is going to equal 5 minus 6. It's going to give us a -1. Our m is going to equal 3 over -1, which simplifies to -3. -2/3 and -3 do not equal each other. So they are not parallel. -2/3 multiplied by 3 is equal to 2. And this is not equal to -1. So it is not perpendicular. So therefore, neither. These lines intersect, but they don't form any special angles. They just intersect normally. They are not parallel nor perpendicular. I drew over it. My bad. But you can see that they are not perpendicular. Let's take a break. I'll be right back.